Good morning, students. So in this video today we shall discuss about stack using linked list or implementation of linked list in stack. So in the previous video we saw the implementation of stack using array. So today we'll be discussing about the implementation of stack using linked list. As you know that array is static data structure and linked list is a dynamic data structure. So there are pros and cons of using arrays and linked lists also in stacks. So linked list implementation using in stacks. Okay, so linked list is a dynamic data structure and array is a static data structure. So size of the array must be declared. So when we use an array in a stack, you must always declare the array. That means the size of the array, the length of the array must be known in advance. Otherwise, uh, the implementation of the stack will not be possible. So that is why it is called as a static data structure. However, in linked list, it is not required to know the size to store the data elements in the stack. So also using linked list, when inserting a data element, there is no need to check if the stack is full, that is overflow, because since the size is not required. Okay, so it is not necessary to check, okay, whether the stack is full or not. Okay, only thing that should be concerned is, okay, if the stack is in underflow condition, that is if the stack is empty or not. That is by using this linked list, right? So I'll just show you a pictorial diagram of, just like yesterday in the previous video, I'll just show you a pictorial diagram, okay, how it is implemented. So adding a data element in this in stack using the linked list. Okay, so here you can see that this is the array elements. Okay, so in this linked list you can see that the first array element is at the bottom. Okay, so first in, last out. Okay, so the first data element that is entered, it will be the last data element that will be popped out. Okay, so first data element pushed, okay, it will be the last data element that will be popped out. So that is in the case of like last in, okay, first out, like that, or first in, last out. So here so this is the so you can see that uh, there are five array elements here. Okay, so this is the top, okay, so which points to the address of the last link that is in this array 4. So this is the data values. This is the data values that is stored in this element. So this contains one element, this contains one another element, like that. So as you know that in a linked list, okay, it takes two array elements, one for the data and then one array element that points to the address of the next data, right? So here I have drawn another block diagram. Here I've included here, this is the address of where this data is stored. Okay, so memory location address of the data element, suppose like 1 is stored in address 100. Okay, so here this one data is stored in the address 100, and 9 is stored in address 204, 7 is stored in address 150, and 12 is stored in address 400. Okay, so you can see that unlike array, in an array the array elements are in sequential order. Also the datas are datas are stored either like in ordered list, okay, sort of format, or the address is in sequential format, suppose like 100, 102, 104, like that. But you can see that in a linked list, okay, the address of where the datas are stored, so this is the first data, and then this is second data, like that. But the address are in random order. This is one of the advantage of the linked list, right? So how do you link this data, that means first, second, third, fourth, if the address are not in sequential order? Okay, so that is by using the second array element. So this is the first array element, and this is the second array element. So using the second array element, which contains the link to the next data, so this will contain the link to the next data, that is 9. Again, the link will contain the address to the next data element, that is 7, like that. Okay, so here link points to the previous data element address in the stack. So since here the datas are entered, the first one is in the end of the stack, okay, the bottom of the stack, and the last data that is entered is in the top of the stack. Okay, so this here, the first data, okay, this is the address, and the link to this address is null. Why? Because link of the first data element is null, since it points to no address, since it is the first data that in the stack, right? So the link to that will be null because it points to no other link. It is the first or head node. So in a linked list, you know that you need a head node. You need a head node or the first node to start the links, right? So that's why this link, the second array element of this link contains null. Okay, now as you can see that here in the second data, the second link is 100. Okay, so how is it? So this 100 is the address of the first data element. Okay, so here link points to the previous data element address in the stack. Okay, so when this data is added or pushed into the stack, okay, so in order to establish the link between this 9 and 1, right, because here the address are in random order, so that is done by this second array element, that is the link. Okay, so which contains the address of the previous data element. So the previous data element is stored in address 100. So when the second data element is pushed, okay, is and inserted, so the link address will contain the address of this first data element, that is 100. Again, when another data is pushed, okay, then suppose like 7, so this is the actual address where it is stored. 7 is stored in 105, but now this 7 in the stack, it is in the third order in array 3, right? So now this has to be linked to this second order. So that the address link of this will contain the address of the second data element, that is 204. Okay, so as you can see that the previous links are attached. So the last one that is entered contains the actual address is 400, but the address link of this contains the link of the third array element, that is number 7. Clear? So this way you link one to the other. Okay, and what about this link? Now this link, since you can see that the top is always left open, right? So the top will store the address link of the top array element, that is 400. Clear? So that why is it stored here? Because after that, right after the last data element, okay, the next will be the top element, right, which will contain the address of that the last or the top array element here. So that is 12400. Why is it stored here? Because like if suppose you remove this, right, if suppose you remove this, then now top will store the address of not this, because this is removed, but it will store this. Okay, which I'll explain in the next diagram. Okay, so as you can see here, the same diagram, I have removed here two data elements. So now there are only two data elements. So now you can see that here top is 200. Sorry, here this is 204. Okay, this is 204. So now top does not store the value 400, but now it stores the the address as 204. Clear? So as you keep on popping out the data elements from the stack, okay, the top element will also element will also keep moving one step down. Clear? And it will store the address of that top element. Clear? So this way you can empty out the stack using linked list also. Okay, but regarding the inserting the data, okay, okay, uh, in a linked list, okay, the overflow condition is omitted. Clear? Only thing that needs to be concerned is whether the stack is empty or not. Okay, so go through this table diagram, okay, try to understand this how it pictorial diagram, okay, and also go through some video tutorial links, okay. So go through the algorithm of that, okay, and then type out the programs. Okay, the programs are quite lengthy, so those things the programs you don't need to memorize, you just go through the program, okay, type out and then check the output here. So yeah, that will be all for today.